Objective 4 is to find intercepts of a rational function. And we've done this repeatedly throughout the course, but now we will do it specifically with these rational functions. To recall that to find x-intercepts of a function y equals f of x, we find the zeros of f by solving the equation f of x equals 0. That is, we set y equal to 0 and solve for x. To find the y-intercepts of the graph of a function f, we evaluate the function at 0. That is, we find f of 0. So in this case, we're setting x equal to 0 and solving for y. So I will illustrate this with a couple of examples. We want to find the x and y intercepts, if they exist, of each rational function. The first one is f of x equals 1 divided by the expression x plus 6 minus 3. So to find the x-intercept, we want to set the function equal to 0, right? Because y is what f of x is, so we set y equal to 0. We get then 1 divided by x plus 6 minus 3 is equal to 0. Recall we solved rational equations in an earlier section. We can multiply each side by the least common denominator, which is x plus 6. So if we multiply this equation through by x plus 6, we get x plus 6 times 1 divided by x plus 6 minus 3 times x plus 6 is equal to 0 times x plus 6. And so simplifying, we get just 1, then distribute the minus 3 to get minus 3x minus 18 equals 0. Combining like terms on the left, we get negative 3x minus 17 equals 0. We can add 17 to get negative 3x equals 17, and then finally divide by negative 3 to get x equals negative 17 thirds. So this means our x-intercept is at the point negative 17 thirds, comma 0. Our y-intercept is found by replacing x with 0, that is, we find f of 0, and get 1 divided by 0 plus 6 minus 3. So this is 1/6 minus 3. We can get a common denominator of 6, and when we convert 3 divided by 1 to a denominator of 6, recall that 1 goes into 6 times, and 6 times 3 is 18. So the equivalent expression is 1/6 minus 18/6, which is negative 17/6. So the y-intercept is the ordered pair 0, negative 17/6. Now we have this function f of x equals a quantity x plus 3 divided by the quantity x squared plus 4x plus 1. So to find the x-intercept, we set the function equal to 0. So that is, we get x plus 3 all divided by x squared plus 4x plus 1 is equal to 0. Then the least common denominator is this x squared plus 4x plus 1. So if we multiply each side by that expression, then we would get that the x squared plus 4x plus 1 divides out on the left, just leaving us with x plus 3 is equal to 0. And then x is equal to negative 3. Therefore, the x-intercept is the ordered pair negative 3, 0. The y-intercept is found by evaluating the function at 0. F of 0 is equal to 0 plus 3, all divided by 0 squared plus 4 times 0 plus 1, which we get 3 in the numerator. The denominator is 0 plus 1, or just 1. This simplifies to be 3. Therefore, the y-intercept is the ordered pair 0, 3.